Okay, thank you. And we can start right now. And Massimo, let me know if it's okay. Audio.
Okay, okay.
Fine. Okay. Speakers details. So we are talking today. There are Massimo. There is Massimo with me. Massimo Pagani is our product manager in GEM International. Is 9-10 years experience in technical support. Is responsible for, let's say, for customer assistance and let's say any product related application related to this area of the process, and is also responsible for joint point between sales and technical department within GMI organization. Myself, Andreas Palora, I'm a global account manager. I was responsible for European market, and I'm following the key accounts within GMI. And that's also, we try to give as much as possible details about the technology, but also the company we want to discuss a little bit about GM International. So GM International is an Italian-based company that design and manufacture a complete range of SIL certified devices in an intrinsically safe solution for the process automation. We are working with the main PLC DCS manufacturer and also in critical application for oil and gas, chemical. About 40-year experience, and the company was founded in 1993. We could have our company in Europe, in Italy, in Milan, but also we have a global presence all over the continent. This is the product range. We produce intrinsically safe barriers or isolators, safety relays, SIL safety relays, SIL isolators, SIL also power supply, so that is also important. There is a part of this webinar dedicated to that. Multiplexer for temperature and digital signal, termination board for main DCS producers, and hard multiplexer, surge protection, and loop indicator. And also we provide functional safety and EX trainings and services. And all our products have been tested and certified from different accreditation bodies, 15. And also we have a functional safety management certification, CA3 systematic capabilities for the design of the product. We invest a lot on the new products, and we provide also 5 years warranty for all products that we produce. As we said, we produce completely in Europe. We have a complete traceability for incoming outgoing product, full testing on all products, and of course, highly automated manufacturing process, like ROS and REACH, also compliance. This is about our organization, different offices, distributors, people around GMI, and also functional safety courses and the installation numbers per year. About our customers, a little bit, so we know maybe you are one of that. So we are divided by system vendors, EPC, OEM, and the users. So we can start, and right now we have the first poll. We can ask you to answer to this poll. Just a very simple question to you, not asking anything in this webinar, just have your opinion on the, let's say, matter. So how important is SIL certification, hazard usare application? We want to ask you, I will tell you why it's important, of course, but for your experience, it's important to know what is, how important it is. Give you another 30 seconds, and then we go to the okay, fine. Thank you very much. And we want to share with you the results. And most of you say that it's very important, SIL certification as hazard usare application. Thank you. You see, and we can go on. Now is let me check it. Well, okay, should be okay now. We can go to the topic. Massimo, is your turn.
Okay, thank you, Andrea. Thank you for your introduction, and welcome everyone also from my side in this GEM International webinar dedicated in its first part to the Smart Relay and their real application. Well, we start with our presentation. Let's start by introducing the concept of SIS, Safety Instrumentation System. SIS is a set of subsystems that make up the safety loop. Within this safety loop, we have field devices such as transmitters or sensors, which allow us to control, detect, and measure variables in the field, such as temperature, pressure, or other. They are driven by barriers or isolators that provides for limiting the current towards the hazardous area or to isolate field instruments. And in turn, the signals sent by the field loop will be acquired, managed, and interpreted by what is the brain of the SIS or the PLC DCS system, which will decide on any action to be taken to make a plan to save. And again, power interfaces, as can be a safety relay, which will then act on a valve and on an actuator, which allow us to bring the SIS in safety in case of need. The main concept that needs to be understood is that every single element of the SIS must be sized with a SIL level, such as to allow us to obtain the overall SIL of the SIS required. All components of a SIF, including power supplies, to which we will dedicate a part of this presentation, must be safety related and have a SIL level. This helps us to have a safety loop and with the correct redundancy, a loop with high availability to the process. But let's start examining those that are a fundamental part of a SIS. Let's talk about safety relay. A safety relay can stop or initiate a movement in a controlled, safe manner by opening, closing valves, start-stop motor, and so on. They must conform and adhere to the ESC 615 and the industrial sector, industrial standard. Not only oil and gas or process industry, but in general, a safety relay can be used where a failure of a relay can cause serious accident to human, environment, assets, or image. Well, but what are the typical cases where a safety relay is required? So typically, we must use a safety relay in all of those applications where the control the digital output card of a PLC, for example, is enabled to activate a field device due to its limited potential in relation to the voltage and current involved. Or in those applications where multiple contacts for the simultaneous activation of multiple loads is required. Or even in those applications where the safety function that the controller must perform needs to be inverted. But what is the difference from a standard to a safety relay? Please, Andrea, it's your turn to explain this difference.
Yes, we can say that standard relay cannot be used in a SIF, so may find in the market different relays for different applications, but those are really standards and you cannot use. That's very important to be understood. So what is a SIL certified relay? Safety relay is a relay with a known warranty ability to perform a given safety function. So that is stated, a guarantee. There is a certificate behind that relay. So, and, what is safety function? Safety function is the ability to perform, to reach a specific safe state on demand. So the simple can be open relief valve, activated fire extinguisher system. So it's a very simple function. can be also start or stop, or open or close. Those are this very simple function, but they must be, let's say, must be performed with very high probability, and that's very important. And the SIL certified relay can give that assurance. So we are talking about ESD, BMS, so where the safety function is normally energized, so you have a normally energized load, and in case of need, you want to de-energize. So de-energize to safety, DTS or DTT, de-energize to trip. That is the most simple functions, and where the safety relay has to perform the function, of course. The other way can be the other applications of fire and gas, where the safety function is normally de-energized, and you want energized to safety, ETS or ETT. I think most of you already know these acronyms, but a safety relay is produced with high-level components, and each of that have a declared failure rate by the manufacturer. So all those data are included to the product F-MEDA analysis. And for each component you see from the table, there is dangerous and safe failure. And those are evaluated in the F-MEDA analysis. So failure can be safe, and the safe can be all detected or undetected. Danger detected and danger undetected. So there are different kind of failure rates, and each of that is, let's say, will be responsible for the failure rate for the relay itself or the product that is claimed to be a SIL. Okay, let's go to real application, Massimo.
Okay, thank you, Andrea. Well, let's look specifically at the difference between digital input relay and digital output relay. Digital input relay are those devices able to managing a voltage-free contact positioned in the field and communicate the status of this contact to a digital input card of a PLC DCS. A typical example is a proximity sensor, Namur type, which is fed and acquired through a galvanic isolator for digital signal. In this case, the sensor in the field is a simple contact free of voltage, which needs to be read and interpreted by our devices, digital input relay in this case. But what happens if in the field we have a wet contact by a voltage, which can differ in value, such as 48 volt, 240 volt, or 24 volt DC, and so on. In this case, digital input relay cannot be used because its input front end is not available to accept external voltages from the field. In this case, we will have to use a digital output relay that is a device that, depending on the voltage that arrives at its command, activates or deactivates an output contact and communicates to a PLC DCS the presence or absence of a voltage in the field. The classic example could be the one where we need to communicate two PLC DCS systems placed in two different contexts. The digital output card of one of the two systems controls our digital output relay, while a digital input card receives the contact status of the digital output relay. What may be the main problem that can be encountered using a relay for this purpose? First of all, we have to keep in mind that usually a relay is designed to switch important values of current, while usually towards a digital input system, the currents in play are very low, typically less than 100 milliamp. In this situation, we can face problems of oxidation of the relay contact. Therefore, it's essential to choose a safety relay with golden plate contacts. which allow us to switch, thanks to its high conductive performance, even currents lower than 10 milliamps. To deal with this problem, GMI has equipped most of the relay of the new D5000 series with golden plate contacts to make them available to this particular application. In addition, GMI has developed a universal device able to receive at its input different voltage level, 24 volt DC, 48 volt DC, 110 volt DC, and so on, selectable via dip switch, while the output provides a free contact voltage, auto-coupled type, compatible with all PLC DCS systems, which ensures maximum conductivity even at lower current. This device is specifically designed to work in this kind of application where we have to communicate between two systems distant from each other, or where we have to signal to a system present or absent of voltage. Well, now let's look at the diagnostic safety relay, commonly called smart relay. This relay allows us to constantly monitor the load and the line in the field and report to our system if a fault is detected in the field. The diagnostic of this relay is active both in on-relay condition and in off-relay condition, allowing us to know the health of the loop, especially for fire and gas application. But why going for a smart relay? Nowadays, full diagnostics is typically required along the full loop. However, many widespread systems do not support diagnostic inside their digital output cards. Smart relay makes diagnostics available to systems that do not support it. In other cases, many modern systems do support digital output diagnostic. However, in many applications, they cannot directly drive the load because they are voltage and current limited, typically no more than 500 milliamp at 24 volt DC. Or when the load, valve, beacon, sounder, etc., require more than 24 volt and or more than 500 milliamp, relay are necessary. And yet, when using standard relay, the digital output diagnostic dies at the relay coil and cannot reach the load in the field. As opposite to that, smart relay can go beyond the typical voltage current system limitation while keeping the full load diagnostics. Even if modern systems can perform load diagnostic, their capabilities may be limited. For instance, air leakage monitor may not be supported, or extreme loads, for example, beacons, may always be reported as an open circuit to the system. Smart relay may offer a solution to extend the digital output diagnostic capability. Smart relay also introduced the possibility of mirroring a fault in the field directly to the digital output card of a system compatible with this function. Let's see in more detail what is the mirroring function on a smart relay. This function allows us to reflect information relating to the field fault directly to the supervised digital output card of a PLC. This is in both in the off state through the pulse test system and in the on state by reading the static return of current. The digital output card of a PLC system can detect the information relating to the field fault. The system, through an upward impedance variation of the relay input circuit, allows the supervised digital output card to see the fault in the field. The system allows considerable saving in engineering cost, as it allows us not to use a dedicated digital input card for this purpose. And again, for this purpose, GMI integrates its range of a smart relay with two models, the D5096S and the D5096S-100. But what are the differences between the two models? The D5096S is a smart relay with fixed diagnostic with the possibility of mirroring a fault in the fin directly to a digital output card compatible with this functionality. This type of relay is SIL-free for both normally energized and normally de-energized application. The mirroring function is performed through a change in impedance, and not all PLC DCSTs are able to correctly read this impedance variation. For this reason, the D5096S-100 variant was created. This new device has the same diagnostic functions as the D5096S, but as an universal mirroring system compatible with all PLC DCS systems, since inside the relay, it's placed in series with the input circuit terminal 1 and 2 in the slide, the fault transistor. In this way, when a fault is in the field is detected, the input circuit is open and an open circuit is shown to the digital output card of a PLC DCS. This relay is SIL-free for normally energized application and SIL-2 for normally de-energized application. Well, let's see what are the diagnostic opportunities that these two relay offers toward the field devices. When the load is activated, the relay contacts are closed and it's able to monitor continuously the voltage applied to the load, the current flowing through the load, and instead, when the load is deactivated, the relay contacts are open and it's able to monitor continuously the power supply voltage, the impedance, the load impedance, and now we introduce another models, the 5294S smart relay with fully configurable diagnostic in all its parameters. This smart relay, in addition to offering all the advantages of the smart relay seen above, adds other features such as a fully customizable diagnostics on the type of load to be used, the ability to read and write data from the module via Modbus RS485, offer an internal diagnostic on the integrity of the coil that make up the matrix of electromechanical relay, and finally gives the possibility to diagnose a leakage between load and earth. Moreover, the relay modules D5294S support Modbus communication over an RS485 cable. Up to 127 modules can be arranged in a multi-drop network and monitored or configured by a single master unit. Each slave contains a table of parameters. Each of them is unequivocally identified through an address and, when requested, makes available its value for reading or writing. What are the advantages of using Modbus communication? With a single Modbus RS485 interface, it's possible to connect and communicate with all the relay present on the same bus. Multi-drop connection is possible and communication can cover a distance of up to 1,200 meters. Another advantage is the possibility of not using a dedicated digital input system to monitor alarms. This allows us to have significant saving in terms of cost. And again, real-time information on the type of alarm and on the health of the load and the line It's also possible through Modbus a complete remote programming of relay. Let's analyze the diagnostic session of these new models, checking what is this functionality allow us to monitor. This smart relay is able to detect a line and load fault, both in energizer relay condition and in de-energizer relay condition. What can we monitor when the relay is in the on state? For example, a typical application could be the monitoring of a normally energized valve. Well, when the load is activated, the D5294S is able to monitor continuously the voltage applied to the load, the current flowing through the load, and also internal coils integrity. This specific model of smart relay has the possibility to performing an internal diagnostic of its coil, and in the event of a fault, report this fault to the system. But what can we monitor when the relay is in the off state? Typically, fire and gas application, where we need to know the health of the field loop. When the load is deactivated, the D5294S is able to monitor continuously the power supply voltage, the load impedance, and the leakage from the load to the ground. In this case, the relay can monitor the leakage resistance between the earth and the load. Now let's examine specifically the typical configuration software of our D5294S smart relay. This model can be also configured when the parameters to be monitored are really specific and the alarm triggering is not achievable with standard monitor relay. It's also possible to monitor the status of the loop in real time with the configurator through a dedicated software called SWC5019 and a small hardware interface. We can completely configure the module. For example, we can set up a window in which the value of voltage on the load, current flowing in the load, and impedance of the load are included. In this way, when the measurement of the variables in the field come out of this window of configured value, an alarm is reported to the system. Through the configuration software, it's also possible to read in real time the value of voltage, current, and load impedance. And in large industrial compound, refinery, etc., for example, double coil valves are normally controlled by a single digital output driver. The double coil avoids the false trip, keeping the system active even if one of the two fails. In this context, the D5294S is again an optimal solution because it can detect the opening of the single valve coil, hence providing predictive diagnostic for prompt maintenance while keeping high availability. Note that the D5294S can set impedance value between 5 ohm and 50 kilo ohms. Let's see specifically how the relay can communicate with the system, how and what are the way in which a smart relay can communicate with the safety system. Smart relay can report the field status to the system in several ways. For example, the first is the two-fold contacts can be acquired by a digital input card of a PLC system. This is a typical way which implies the use of DCS with a dedicated digital input card where the status of a contact called a fault is monitored by the system. The second method, if the system digital output card driving the smart relay support part testing, the fault in the field can even be mirrored directly to the digital output card without the need of an additional digital input card. And again, the fault on bus can also be acquired by a system digital input card. The fault on bus is normally used when a cumulative report from many modules is required. And last but not least, complete diagnostic information can be retrieved through Modbus multi-drop RS485 protocol if a master module if the master is available on the system side. Remember that through the Modbus protocol, the relay can be constantly monitored and also configured remotely. Let's see in more detail what is the mirroring function on smart relay. This function allows us to reflect information related to the field fault directly to the supervised digital output card of a PLC, both in the off state through the pulse test system and in the on state by reading the static record of current. The digital output card of a PLC system can detect the information related to the field fault. This system, through an upward impedance variation of the relay input circuit, allows the supervised digital output card to see the fault in the field. This system allows considerable saving in engineering cost, as it allows us not to use a dedicated digital input card of a DCS for this purpose. Well, Andrea, I leave you the words to explain the difference between safety and availability on the relay.
Yeah, thank you, Massimo. Just one thing more about the SIL. We have talked about detected failures, dangerous failures, and safe failures. And for each part, there is a safe, detected, safe, undetected. But I talk about always safe failures. Safe means that it will not lead to a disaster. But there are also the dangerous, and the dangerous can be detected and undetected. So the difference between that is very important, because if it's dangerous but it is detected, the failure is, I can say, act in advance. But if it's not undetectable and is dangerous, that is a really problem. So those parts like safety relays and also the monitoring functionality we are going to explain later on, say, move and they became the undetected failure in detected. So in this case also save a lot of say from happening disasters, because if I move the undetected to detected, that is my goal, because I can detect any single failure, and the monitoring functionality are useful for that. So here in this slide, we are talking about safety. So the safety meets the demand for functional safety on the basis of IEC 61508 for the manufacturer, and IEC 61511 for the system integrator, like probably you. Those are the safety standard for the processes. So a device would be safe is able to perform a certain safety function where required. So open, close a valve, start and stop mode. That is the most important application. But also, beside that, there is the availability, which is also very important. So it can be defined as the proportional time for which the equipment is able to perform its function. Availability is different from reliability, that takes in account the repair time. So an item of equipment may not be very reliable, but it can be repaired quickly when it fails. So its availability could be high. If a power supply fails during normal operation, its availability is lost, so power is off. So in our relays, as you may see, there are 4 relays inside that are very interesting, because coming back to safety and availability, those are of course safe because are SIL3 certified, okay, but also are grants the availability. So it means that in case one single release of the 4 fails, I can, let's say, keep maintain my safety function available. That is very, very important, because especially if I'm using the monitoring relay where I can detect the single coil failure, I can, let's say, be alerted about that failure, and I can replace the relay without losing my safety. So Massimo, please explain the important applications.
Okay, thank you, Andrea. Now we try to analyze some real application in relation to different types of load and the importance of the end-of-line resistors. Take, for example, a sounder. Typically, those devices, especially in the off condition of the relay, show to the later very high impedance, often outside the diagnostic range of the smart relay, or in the on condition of the relay, they show for a very short instant a full condition due to the capacitive front end of the device. These problems often occur with these types of field devices, and to overcome them, it's necessary to insert resistors in parallel to the device itself, which allow to bring the impedance value of the field device within the diagnostic values of the relay. In other cases, however, these field devices, again, due to their strongly inductive or capacitive front ends, generate strong reverse current peaks, which risk irreparably damaging the relay contacts. To overcome this problem, it's necessary to insert protection devices such as PTC or power resistors, able to dampen this dangerous peak. As we see in the slide, these protection devices are placed in series with the field device, while the end-of-line resistors must necessarily be placed in parallel and as close as possible to the terminals of the field device. The value of these resistances, or PTC, must necessarily be evaluated from application to application based on the value of the load supply voltage. Another application involves the safety relay can be connected in unipolar or bipolar configuration. A bipolar connection allows a complete isolation of the load, and this is recommended especially in the application where the load must be powered with high voltage. From an electrical point of view, this type of connection grants a great safety thanks to the complete isolation of the load. Instead, a unipolar connection isolates the load only on one of the power supply lines and bring a negative to earth in case of need. Furthermore, this type of connection saves a lot of cable cost. Only as regards the D5294S model, it's possible to configure the relay to have a diagnostic on the field device, even in condition of load connected in a unipolar mode. Of course, we must consider the bipolar type connection as ideal and standard for an optimal functioning of the relay diagnostic. However, the D5294S guarantees, even if in a reduced way, a diagnostic of the field device connected in unipolar mode. It must be configured via software and connected as shown in the slide. In the on state, it will be able to monitor the current circulating in the load. In this way, it will provide us with information on the health of the field device and on the loop connected to it. With the relay in off state, we will be able to monitor the power supply voltage of the load. Well, Andrea, we finished the presentation of the smart relay.
Thank you, Massimo. We wanna just ask you this point about the feature for safety relay. Do you consider as relevant? Is a multiple choice. This, of course, this is anonymous. We don't see your answer. You can answer freely, whatever you like. I hope that will be very interesting for you because we think that monitor relay are more and more required in the market because of its features and also capability like such Modbus is an added value we try to add to our products. And thank you for answering. Give another few seconds and then we stop. So we go to the next part, which is dedicated to the physical safe isolators, where we have based our experience, long experience. Okay. Thank you for answering. Oh, all features are more or less equivalent to you. Very good. So you need all of that. Good. Okay, thank you. I'm stopping now. So I want to share with you, so this part, probably threshold is most important for you, but I see also past test compatibility is very important. Fault mirroring on the O card. That fault mirroring is another feature, is very important because we can transmit over the DO output all the faults or a part of the faults in both cases, in a normal energize and in case also normal de-energize, which is quite unique. Okay, I'm stopping now. And let's go to the next part where I will be your speaker. So we are talking about IS isolators and specifically line monitoring, line fault detection. So, sorry. Okay. So just to give you an overview, we have a wide range of IS isolators, very small. So an IOS system basically could be wired by a single power bus system, and optionally we have a module for power redundancy and the common fault reporting if required. And but we know that along the AIX certification, the modern application SIL is more and more required. It's important, the SIL certificate is important for the reliability of the application. So basically we see that the minimum SIL level is nowadays required in a lot of application for IS isolators. But what is very important is the line monitoring, because we are always be asked by our customers what if we can grant these features, and then now we want to explain why we can grant. So we can say analyze first the line monitoring capability for analog inputs, okay? From say that 4 to 20 milliamps fluctuation, we prove the presence of the line, and the values that are lower than 4 milliamps or higher than 20 milliamps are indicating that there is a failure. So there is a band outside of that, there is a failure. That's clear for you, of course, I think. But our isolators reflect transparently up to 26 milliamps that value. So there is no indication in the module, but if I'm using NAMUR compliant transmitters that have a value lower than 3.8 milliamps or higher than 21 milliamps, that values indicated that there is a specific failure. So the analog signal basically is not, is never a problem. Analog output is a little bit different because we have, for instance, this kind of solution. So there is this the D5020. When there is a loader resistance, which is lower than 50 ohm, that is set by our module, or 100 ohms, okay, you can have two, that is detected as a short. In case also when there is a resistance which is connected to the 420 milliamp signal, so the current, but is, let's say, greater than basically 750 ohm, that is detected output, open output. In this case, in both cases, the D5020 reflects an high impedance on the system side and is forcing 2 milliamps to the system. So supervised analog input card from DCS, we were asked from one of you from system ABB Honeywell. We are working all days with those kind of system, and on those systems there are cards that can be supervised and non-supervised. If I use supervised card, that will be, in this case, high impedance will be read as a fault from the system. If you are not using supervised card, this unit have a fault out. So that fault out is will be energized and connected to the digital input of your system that will be sign of a fault. For digital input is a little bit different because we basically there are units suitable for SIL2 or SIL3 application also. But also for our input we have this kind of possibility, but let's focus on digital input. We realize those kind of systems that have a module that have the drawing there. You see the output to the system, that how it's working. There are two contacts you see on the left, on the top side. So basically, when the contact is out, is open, so there is open contact, and the system is reflecting the addition of RL resistance. When it's closed, the system will see only RL. So there is a difference from system side of the value that resistance that the system will see. Okay. And in case of fault, when there is a short open, there is this contact will be open. Okay, this contact will be open. Sorry, on the top, and that will be revert very high impedance to the system. In this case, I know that there is a short or open circuit on my field. That is how we can detect 24 normal signal, digital signal. There is also a solution for a proximity digital input card where there is a module that is operates as a current generator and reflects its current levels to the for different states. You see from the blue table, there are different current values corresponding to different status, open or close, or fault, like open short. At the end, digital output operates more or less like an analog output. In this case, there is I can detect the load, the open circuits when the resistance is higher than 10 kilo ohm, or short when the resistance is lower than 50 ohm. That will be reported as we report high impedance to the system that will be detected as a fault. In this case, there is also a fault output in case you may want to acquire that as from a digital input card. That's practically all regarding the IS isolator. If you have any questions, I see that some of you are writing something, and we can now I'll try to answer by writing, and otherwise we'll tell you. And leave Massimo talk about the power supplies, which is the last part for this webinar.
Okay, Andrea, we can start with the last part of our webinar. In this part, we will treat power supply system. But before going into the specific of the operation of a safety power supply system, let's see a quick representation of the products offered by GMI in this field. The power supply safety system can be composed in racks of up to 6 elements, each of which with 50 amperes, 90 each rack with onboard diagnostic module, or alternatively, we can have a 9-inch rack with two 50 ampere power supplies on board plus a diagnostic module, or again a 7-inch rack without a diagnostic module. All our racks allow the redundancy of the power supply modules to obtain different working configuration. Finally, it's possible to obtain single modules of 50 amperes or 20 amperes, which can be placed in parallel to have up to 10 modules connected in current sharing between them. Now, let's take a look at the power supply. What are the possible risks and conditions that we consider dangerous in relation to the use of a power supply? The concept of safety is very important also with regard to power supply system, because the failure of a power supply can cause serious accidents that lead to serious loss in terms of human lives, serious environmental damages, and serious cost losses for companies. For this reason, it's necessary to have safe devices that guarantee high performance. But what are the dangerous conditions for a power supply system? Well, mainly there are two dangerous fault conditions. The first one is an undefined load voltage in a range between 2 and 20 volts. Must be considered as dangerous failure of our power supply. This is because an incorrectly powered load works or can work out of specification, and this leads to a reduction in a load performance that can cause a premature instrument failure. Often we try to avoid this issue using redundancy, but we wrongly think that two power supplies in parallel are sufficient to make us immune from possible faults in the power supply system. Redundancy cannot solve on its own and cannot guarantee us immunity from power supply failure, because a standard power supply system, it does not take into account the common mode faults that can afflict standard power supplies. These common mode faults can cause serious spurious system faults with the related production downtime, which would significantly affect costs. The redundancy of safety power supply minimizes the risk, because common mode failures are considered in the SIL calculation, necessary to get the certification for a safety-related device. The second dangerous failure condition of a power supply system is when the output voltage reaches a value higher than 30 volt. In this condition, the load is subjected to an extra voltage, which can damage it. Or in case of output voltage higher than 50 volt, the field instrumentation can suffer a definitive disruption. We can take, for example, an engine cooling system, which works thanks to a standard power supply. Suppose that the standard power supply fails and goes into an overvoltage condition, damaging the cooling system. This will lead to an overheating of the engine, which will lead to serious consequences for the whole system connected to it. A safe power supply system grants high performance and high safety. So why it's correct to use a safety power supply system? Below are the main reasons that lead us to advise against the use of a simple standard power supply. A standard power supply is not designed based on the directive of ESC 61508. It does not have made calculations defined for the safety function to be obtained. It does not allow to have redundant protection from overvoltage issue, while as in a safety power supply system, redundant protection are a fundamental requirement. And again, standard power supplies can be used in a redundant configuration, but they do not guarantee that our application is totally safe for the reason related to common mode faults which we have seen previously. And also, standard power supply often require external O-ring diodes for redundancy. This means to add external wiring that, especially for high load currents, creates an high voltage drop which has a strong impact on the supply voltage. It's true that it's possible to adjust the output voltage to compensate for the voltage drop, but this operation increases consumption considerably. In addition, a standard power supply has a higher number of spurious faults than a safety power supply. We know well how a spurious fault can also lead to dangerous failures for the application. And also, standard power supply use internal components with limited operating range to keep cost down. This affects the lifetime of the device. For this reason, internally to the safety power supply system are used components with an higher operating range that allow the system to work at a lower stress level. This leads to less failure and consequently a considerably longer lifetime than standard power supply system. At this point, why it's important to use a safety power supply system? First of all, we know that the standard voltage for a normally energized load is in the 24 volt DC range. As we have seen previously, conditions that lead to power supply output voltages between 2 and 20 volt and higher than 40 volt are considered dangerous failures, which negatively affect the application. Well, a safety power supply significantly reduces undetected dangerous faults thanks to a built-in diagnostic system. In fact, if an anomalous output condition is detected by the safety power supply diagnostic, it brings the output to 0 volt, which represents the safe fault condition. Plus, a fault transistor alerts the PLC system, which can act as per SIL specification. And huge advantages that safety power supplies give is the presence of the O-ring diodes inside the device. This grants a huge cost advantage, as it's not necessary to externally wire the diodes for each unit that is part of the redundant power supply system. GMI power supply do not require external O-ring diodes for output parallel configuration because each GMI power supply has got internal. It's got internal an active ideal diode realized by MOSFET and related control circuit components, replacing all methods with Schottky O-ring diodes. This increases efficiency, reliability, and availability, and reduces space about not use Schottky diodes in sync. MOSFET active ideal diode with related control circuit provides also very smooth voltage switchovers without oscillation with fast turn-off, minimize reverse current transient. In the next slide, we see advantages that the ideal diodes system inside a safety power supply system brings compared to an old standard power supply. Here we can see for example, a voltage drop at 50 ampere, that for the old Schottky diode system is 0.8 volt. Instead, in the new safety power supply system of GMI, the voltage drop at 50 ampere is only 0.06 volt. This allows us to have a low power dissipation at 50 ampere, only 3 watt for the new GMI system against 40 watt with the old Schottky diode system. Well, this purely hardware control is complex and based on output current measuring that each power supply module execute. Typically, load current sharing capability is a necessary feature for medium and high load currents. All GMI power supply can be paralleled on their output and their internal load current sharing circuit operate to distribute current load equally to each power supply module to increase reliability and reduce internal power dissipation of each module. Another advantage of load current sharing functionality is request of little system output voltage modification when 2 or more PS modules are normally operating. And finally, another important feature is the short circuit proof system. This system avoids that in the event of a short circuit of one of the load connected to the power supply system, there is no system shutdown. In fact, when the protection circuit detects a short circuit on the line, it sends a current peak that can reach up to 800 ampere for a maximum of 0.5 milliseconds, able to interrupt the protection fuse or the circuit breaker associated with it to interrupt the power supply to the short circuit load and safeguard the rest of the system. Well, Andrea, we have finished the presentation on the power supply system.
We finished everything. Thank you very much, Massimo. And we remind you that you may find any value information on our website, such documentation, product details, certification, use software. Contact one of us and our subsidiaries. If you have any question, we can answer right now, or you can write later on. And we remind that there are a lot of webinars. We are also having new topics for this year. Especially, I come back to the initial things. If you want more details about SIL, function safety, about function safety management, or SIL calculation, whatever, we have a specific webinar dedicated to that with our special team on the Capelle. Or if you have want to have details about EX application, that is also very important, especially EX, normative and what to use when. We have also a lot of different webinars with Bob Johnson, our specialist. You find here on our calendar, so you can attend to those. This webinar, the other, have been recorded, and you can see later on our YouTube channel. Thank you. If you want to answer, don't know if was what you expected, but we kindly ask you to answer to this question. And that is anonymous, so please don't hesitate. Write what you like, and if you have any comments, you can write to us. If you want to have specific arguments, we may do this, we can organize in the next month. And also we are willing to organize some in-house for your company. If you have any certain number of people you want to discuss freely about certification, you can have a lot of experts at Jamal. Thank you for answering, and we are going to close. You are too good with us. Thank you very much. And what else? Last point is our face, names, and emails. If you want to write us, contact in the future, don't hesitate. Thank you. And we have maybe another question. If we can tell you live, maybe it's important. We have this device that compared with the IEC 62543 standard cybersecurity. Yes, we do have it. We are going, not now, but we are going to have it. And thank you very much.
Thank you, Andrea. Thank you all for your attention and your participation in GMI webinar. Thank you.
Thank you to all of
See you
you.
in the next one.
Bye-bye.
Bye-bye.
Ciao,
Ciao, ciao, Andrea.